In this example, I'm going to find the resonant frequency for the given circuit. So here, first convert into frequency domain. First convert the given circuit into frequency domain. So this is going to be j 100 omega, and this is going to be 1 over j omega 5 milli. So 5 milli. If I take the milli to the numerator, it will become 1000 divided by j omega times 5, and then that's 200. So it's going to be 200 over j omega. Now those two are in parallel. So j 100 omega parallel with 200 over j omega. Now when I combine those two, j 100 omega times 200 over j omega divided by j 100 omega plus 200 over j omega. Now I need to eliminate the j omega in the denominator. So to eliminate that, I'm going to find the LCM of this denominator. So it's going to be j 100 omega times 200 omega. I can write it as j 220 times 10 to the power of 3 omega over j omega divided by j square 100 omega square plus 200 divided by j omega. J omega get cancelled out, so we'll end up with j 20 times 10 to the power of 3 omega over j square, which is -1. So 200 minus 100 omega square. That's the j part. So our z total must be 200 plus j 20 times 10 to the power of 3 omega over 200 minus 100 omega square. Now what is the imaginary part here? I see the imaginary part. This is the only imaginary part. That must be equal to 0. So to find out the resonant frequency, imaginary part must be equal to 0. So at resonant frequency, imaginary part equal to 0. So 20 times 10 to the power of 3 omega naught over 200 minus 100 omega square must be equal to 0. Omega naught. So basically here this must be omega naught equal to 0 at 0 frequency, at 0 hertz, at 0 radians per second. The circuit will have resonant frequency. Other than that, it will not have a resonant frequency. Okay. Thank you.